Now that we're comfortable with the why of why we do something to both sides of an equation, let's see if we can apply it to some equations to solve for an unknown variable. So let's say that you have x plus 7 is equal to 10, and I want to solve for x. All it's saying is something plus 7 is equal to 10. And you might be able to figure out in your head, but if you want to do it a little bit more systematically, you're like, well, all I want on the left-hand side is an x. Well, if all I want on the left-hand side is an x, I'd want to get rid of the 7. I want to subtract 7 from the left-hand side. But if I want to maintain an equality here, whatever I do to the left-hand side, I also have to do to the right-hand side. Going back to our scales, that's so that we can keep our scale balanced. So we can say that the left is still equal to the right. And so what we're going to be left with is x, and then the 7's cancel out, is equal to 10 minus 7 is equal to 3. So that unknown is 3. And you can verify it. 3 plus 7 is indeed equal to 10. Let's try one more. Let's say we have a minus 5 is equal to negative 2. So this is a little bit more interesting since we have all of these negative numbers here. But we can use the exact same logic. We just want an a over here on the left-hand side. So we have to get rid of this negative 5 somehow. Well, the best way of getting rid of a negative 5 is to add 5 to it. So I'll do that. So I will add 5 to the left-hand side. But if I want the left-hand side to stay equal to the right-hand side, whatever I do to the left, I have to do to the right. So I'm going to have to add 5 on the right-hand side as well. And so on the left-hand side, I'm left with a, and then the negative 5 and the positive 5 cancel out. And on the right-hand side, and they're going to stay equal because I did the same thing to both sides, we have negative 2 plus 5, which is equal to 3. So a is equal to 3. Once again, you can verify it. 3 minus 5 is indeed equal to negative 2.